Come and take
Okay, come. Integration by parts. Now, first of all, you need to understand that there are few things that you cannot integrate still. Okay? And the few things that you cannot integrate still, that means integrate directly. So, ln x, sine inverse, any inverse, all you cannot integrate directly. So, this is what we're going to do using by parts to do. Okay? So, integration by parts is not anything too foreign to you because it is, after all, just integration. It's actually from the product rule. Okay? So, if you were to pay attention to this proof, right, what you see on the screen now, pay attention people, this is your O-level stuff, right, when you first learn your product rule. So you keep the U, differentiate the V, plus you keep the V, differentiate the U, correct? So if you were to integrate the the right hand side, you will get back the left hand side. Makes sense, right? So what you do is you split into two and you bring one integral over the other side. So this is a general formula that you actually see in your notes, I believe, right? Okay, and this is what a teacher will have taught you to use, right? Let U be something, let V prime be something else, and then after that you go and sort out what's your U and what's your V and whatever nonsense. Okay, now I don't like to use this version of the formula. Okay, the reason because it's very troublesome. Now I'm quite sure, let me just write out this one. I'm quite sure you don't know how to do your product rule properly, right? In your O-level days. Agree? Right? So last time when you learn your product rule, when you do this, differentiate UV, then you V and then dV dx. Agree? Then plus V and then du dx. Now when you encounter a question like this, differentiate x sine x. Did your teacher really ask you to go and let U be x and then let V be sine x? Anyone of you teacher actually asked you to do that? No, right? You don't care. Honestly, you don't really care. Right? You just go straight away, go differentiate, right? Oh, just keep x. You don't really need to show this, right? Because
we need to write. We do it.
Yeah, so waste time.
No, but I think I'm more accurate.
Waste time only. No, it's just waste time, seriously, because you should be very confident in this, right? Keep this, keep x, differentiate sine.
Now can about in secondary school you didn't.
Nah, that's why secondary school you should have done it. Okay, kind of. Now same thing for by parts. If you do it that way, you are doing the same. So it'll be waste time. So there's a more direct way, which is obviously faster, and it makes you look more cool. Alright, not just make you look more cool, but also there are questions whereby you need to by parts twice.
Yeah.
So if you only know how to let U let V, then that kind of question, I'm quite sorry lah. You're gonna look very unwieldy. Damn it, huh? Okay, so come, let me go through review what are those. What is the thing that I'm going to tell you about? Okay, so come, integration by parts. Alright, now this one you really gotta pay attention now for the next 5 minutes. Okay, so I really need your full attention so that you can learn this proper. Alright, learn this proper. Now, integration by parts is not just to integrate things that are unintegratable. Unintegratable, that means not integratable, okay? Now, it is also to help you integrate products like this, f and g. So, there are two functions. So, how we do it without letting u, letting v? I'm quite sure your teacher taught you let u be this fx, let v be the whatever lah. Then you go and solve all the things, right? Waste time. Okay, I don't like it. And when I see my student do it, I want to cry, huh? So especially your J1, you have long time to go, so I want you all to learn it properly. So how to do this? Come, pay attention. Pay attention. Pay attention, please. Okay, come. Right. First of all, you keep one of them. You keep. So you keep the f. Let's, for example, you keep the f. Okay. And then you integrate the g. Understand? So you go integrate the g. So integrate the g, you get big G. Okay. So you keep f, integrate g. Minus away the integration of the one that you kept, you haven't done anything to it, right? So what you do? You go and differentiate. And then this one you already done something to it, right? Then you copy the same thing here. Then you integrate one more time. Then this is your by parts. Okay, one more time. Keep the f. No, I'm going to show you an example. Don't bother about this because it looks awfully complicated. Now, to be honest, when I first learned this from my tutor, I think that this is a lot harder than the let u let v, because let u let v is like so simple, right? You just follow the formula, can't go wrong. But eventually I find that this is a lot faster and it makes you more confident also. We do things in one step, people do a few steps, you do one step. Alright, so pay attention one more time. Keep one of them, integrate the other. So in this case I keep f, integrate the g, minus away the integration of the one that I kept, I haven't done anything to it, right? I go and differentiate. And the one that I integrated, right, I copy it here. Okay, then this is a product that I simplify and I integrate one more time. That's the by parts. Okay, So it sounds very complicated now. Let me show you one particular example. Alright, now let's say I want to integrate x ln x. Okay, now pay attention people, see how it works. Okay, now which one to keep?
X.
Should be your problem. That should be your question that you should be asking. Alright, in this case it's pretty obvious we have to keep the ln. Why we keep ln? Because we cannot integrate ln. Agree? We cannot integrate ln directly.
Is it the LIATE?
Yes, LIATE thing. Alright, so we'll talk about it later. Okay, so in this case it's very obvious, so no need the LIATE, right? So obviously we keep the ln because we cannot integrate ln, right? So we keep the ln, we integrate the x. So can you integrate x or not? Mentally, come on.
1.
No,
sorry.
Half x squared?
Half x squared, very good. Okay, so we keep the ln, integrate the x, minus away the integration of what?
Differentiate the ln.
Differentiate the ln, exactly, because we have.
Keep the.
Then this one just copy x squared over 2.
X over 2.
Okay, and of course you simplify, right? And you're almost done, you know, halfway through already. So this one is, there's a half,
Constant.
then there's a half, right? It's a half, right? Integrate half, you don't tell, integrate x, sorry. That's it. Understand or not?
So you do have to put constant on the first line.
No need because haven't fully integrated, but it's okay, this constant.
So
Do you understand? Let me nag again. Correct, very important. You see, I keep the ln, I differentiate the ln. So basically there's one thing that you keep and you differentiate. Then there's another one that you actually integrate. And then you integrate only. Understand? Okay? Now, so this is what we call the Kimsey rule. Alright? Kimsey, by the way, is not invented by me. It was by one of my SA students who told me. Okay? So anyway, this is something like the proof lah, but I think it looks awfully complicated, right? But if you want, you can go back and take a look. It's basically what I just showed you. But most important is this highlighted part.
What is it called?
Here we call it the Kimsey rule. Let me explain why is it called the Kimsey rule. Okay? Yeah. Alright. Why is it called Kimsey? Pay attention. Kimsey is spelled this way. Sound like some Korean word, right? Kimsey, no S. Hold on, Kims.
S.
Yeah, D. Yeah. I pay attention. The K for keep. Yeah, keep. As well. I for integrate. This one is integrate.
Minus.
M for minus. The S, where got S? S is this tauge here. This is the S.
Looks like S.
Looks like S. Wow. Then this one is the differentiate. D for differentiate. Then the I is the same I, the integrated one. Kim's D. Okay now, but trust me, you don't need Kim's D. You just need to practice. Like, do this 5 times today, you master it already. But you must try. Okay, and some of you are J1. Like J2s, I usually you know, sometimes because they are so used to the U and V thing already, so it's quite hard to teach an old dog new tricks sometimes. Okay? So, do you understand? You are going to try this one. I want you to try using this, not using the U and V thing, okay? Now, but of course, the bigger question that you should be asking is this. Ms. Tang, then how do I know what to keep?
Why my school use LATE?
Doesn't matter, because I think LIATE doesn't make any sense. So I change it to ILATE. Make more sense.
So you get inverse trigo and ln and
then die, because both are not integratable. Won't happen, right? So don't worry. Yep. Okay, so I changed it to ILATE. I think ILATE easier to remember. I don't know. Liat, spell wrong how?
No, Liat.
Okay lah, maybe you used to it, that's why lah. Okay, so I also learned Liat, but I think Liat doesn't make sense. So I think ILATE is easier. Alright, pay attention people, what is this ILATE? Think of it like a spectrum. It's a general guideline, it's like a spectrum. So anything on the left you keep, anything on the right you integrate. Alright, so I stands for inverse trigo, L for ln. Now these two things are the things that you cannot integrate anyway. Right?
Also cannot.
Integrate inverse confirm cannot. You cannot integrate directly. Understand? You cannot integrate like integrate ln, you immediately get an answer. No. Okay, you also have to use by parts, and there's a trick to it. Okay? Algebra, that means anything to do with x. So for example, the previous example we have, right? This one, right? This is L for ln, and this is A for algebra, right? So we have algebra and ln. So algebra and ln. We will keep the ln and integrate the algebra. Understand? Contrary to some teachers, I heard some teachers, my students might tell me that teachers told them, you always keep the harder to integrate one. That sounds really wrong. Anyone of you actually learn that or hear that?
Why is it wrong?
Because what do you mean by harder to integrate one? For example, let me show you another one. Let's say I want to integrate x sine x. Which one do you think is the harder to integrate one? Some people may think that the sine is the harder to integrate one, right? And some people may think that x is harder to integrate, right? So it's so subjective. Okay, and not only that, if you keep the wrong one, this question cannot be done. No? So ILATE, come, let's try ILATE. Let's see how ILATE works. Okay, algebra and trigo. So which one do you think you should keep? We should keep the trigo. Alright, understand? People will think that, hey, you know lah, we go and keep the x this one. Eh?
Algebra is A.
No, we should keep the algebra lah.
Yeah, that's
Oh,
why.
yeah, keep the algebra.
Sorry,
Integrate the
but
trigo.
in my mind, which one should I integrate?
Yeah. Okay, so we should integrate the trigo one. Yep. Understand? So if you do the opposite way, you will get hang, no? Yeah, you want to try? Let me show you. Okay, let's say oh, I keep the one that's harder. All right, so I keep sine. Then I go and integrate x. Okay, then I go and differentiate my sine and get cos, right? And then I keep this. Now take a look at this. Another by parts.
Yeah.
And you know what? And if you do the same thing again, you have another by parts, and you have another by parts, and you have another by parts. Okay, because the sine becomes cosine, cosine becomes sine, sine becomes cosine all over again, right? Get the idea? So you must choose the right one to keep, choose the right one to integrate. Are you all clear? Can? Okay, let me show you a few more examples quickly. Then you go and try.
Exponential.
Exponential is e power something, yeah.
Oh.
But I want to show you this ln x. Do you all know how to integrate ln x?
1.
Yeah, put a 1 in front. You all know that already?
Yes.
Can? Oh no, then I don't show you lah.
I don't know.
Are you sure you don't know?
Sure.
Okay, I'll show you. Come. Okay, like I said, you cannot really integrate ln x directly or you know, directly as it is. So the trick is to multiply a 1 to it. So now it becomes a product, right? So when it becomes a product, you can do by parts, right? Yeah. So you keep the ln, integrate the 1, minus away, differentiate the ln, and then this one. So yeah. So if we've practiced, trust me, I think this is a lot faster. There you go. You see, I can do it in so short a step rather than a few more steps than necessary. So far so good? Okay, now these are the easier ones. Now, but I want to show you a few type of questions whereby it's a bit more special. Right, integrate twice in order to get the answer. Okay, there are quite a few examples here. Choose one, like A, B, C. C don't, C don't. We do B, B. Okay, EX sin X. How about that? Yeah, come. Let me show you EX sin X. No space. Okay, now let's say I want to integrate EX sin X. Pay attention, people, because I'm going to throw everything at you, and then later on you go and try doing. Okay.
Integrate the exponential.
All right, come. Which one shall I keep?
Exponential.
Keep means the one I need to differentiate. So this is E, right? Yeah, keep the trigo. Okay, very good, very good. So I keep the sine, I integrate the EX. I get EX all, right? And then I minus away the one I kept. What do I do?
Differentiate.
Very good. I differentiate and then
Keep
EX. Make sense?
Yes.
Okay, but then Mr. Ang, another by parts, no? It's okay, do it again. So you do it again, put a big bracket. Ayo, this bracket so ugly. Put a big bracket, do another by parts. So we keep the cosine, right?
Yeah.
Integrate the E again, right?
Mm.
Minus away the cosine, we now, what do we do?
Sine.
Differentiate.
Negative sign.
Negative sine.
Yeah.
Then you go like, Mr. Ang, this is endless, again. Now hold on, chill, okay? This is where you got to chill.
Move over.
Wow, you very clever, no? You. How come you everything also know?
Do it in school.
Because it's the same thing.
So this one becomes plus, but you take out bracket, become minus. Are you all clear? Don't make this kind of silly mistake, okay? So you should be able to tell that the left hand side and the right hand side got something in common. Right? Suddenly the same original question appear again. So what you do is you bring it over to the left and you get 2. Agree? Then whatever you have here, you just copy. Okay? And then what you need to do is just divide by 2 and then get the answer. Okay? So this type of question is, yes, the kind that whereby you will see the question itself. Generally, at most generally, as far as I know, you only need to integrate by parts twice. Okay? Very seldom I will see a question that you need to integrate by parts 3 times.
Meaning
No.
we can stop.
You better be able to stop somewhere.
And we
Yeah.
see the same thing.
Yeah, same thing, you know you can stop and then you bring it over. Okay? Alright, so this kind of example, watch out for it. Okay? Not say super common, but it's around
Yeah,
there.
as a 3 to the power x is considered exponential.
3 to the power x is exponential function, yes. Okay, how about this one? This one is just point, I think you should be able to understand, okay? So it's also exponential algebra, right? So we keep the algebra, integrate the exponential. But you realize that here, there is another by parts. Okay, and this by parts you have to do another time to resolve the x, and then you have no more. So basically you integrated total of 3 times. Oh, you have to do integration for 3 times here. 2 times by part, 1 time is the normal time. Okay, so there are questions like this. So far so good? Okay, very good. Now your turn to try. Okay, Kylie, turn to your... this one is quite difficult. No? Got time, you all may want to try.
One, right?
Secant cube is quite difficult.
That one, right? Go up.
Oh, sorry, which one?
Just not the one going through.
This one, A, is it?
Then you integrate that thing.
So there's another by parts. But this one won't repeat, so you won't see the question appearing. So you cannot move to the left. You have by parts and then by parts again, and then you will be able to resolve it. Because you will see that the x square after you differentiate become x. Then the x after you differentiate one more time, no more. Get the idea? Yeah, so you just differentiate at most twice. Do by parts twice. Okay? So kindly go to your hands-on practice now. This one I really want you to practice well and practice properly. So I need you to do all. Okay?
I need to go soon.
Go where?